today's class, we'll be discussing with respect to importance of dissolved oxygen in the water. So, oxygen present in the dissolved form in the water, we call it as dissolved oxygen. It has got its own environmental significance. The aquatic life, like fishes, require dissolved oxygen for their survival. The dissolved oxygen concentration in the water should be more than 4 mg per liter. If it is less, then the aquatic animals are going to get killed. Apart from that, the domestic water supply should not have more amount of dissolved oxygen in the pipeline. If more amount of dissolved oxygen is present in the water supply line, and if the water supply lines are of cast iron or mild steel or galvanized iron GI pipe, in that case the corrosion rate is going to be more. The rate of corrosion is going to get enhanced. So to see that this water supply lines will not get affected, even after treating the water, the dissolved oxygen should be checked for less for the value of less than 8 mg per liter. If it is more, then the corrosion rate is going to increase. Apart from that, if we are checking for the organic pollution of the river, the first thing we'll be checking is the dissolved oxygen. Provided we are going to collect the grab samples in the morning, not in the afternoon, because in the afternoon the sunlight will be more, the temperature will be more, and because of this the dissolved oxygen will be less. That means we will not get the correct reading, and at that time we should not come to any wrong conclusion stating that there is organic pollution in the river. No, definitely not. Because of increase in the temperature in the afternoon, there will be decrease in the dissolved oxygen concentration. So in the morning, usually we'll be collecting the water sample and we'll be checking for the dissolved oxygen concentration in the sample. So during which, if the observation is something like DO less than 4 mg per liter, then we can come to some conclusion that there is some thermal pollution or organic pollution. So overall, dissolved oxygen is going to act as a baseline for carrying out biochemical oxygen demand test. Anyway, when I'll be discussing with regard to BOD, that is biochemical oxygen demand, so at that time I'll be again talking more about dissolved oxygen. So dissolved oxygen is required for aerobic decomposition process. That means if we are treating the water by aerobic bacteria and facultative bacteria, then dissolved oxygen concentration in the water or wastewater is going to play a very important role, right? Oxygen is important factor in corrosion. So that means this dissolved oxygen should be controlled not only in the water supply lines, but also in what you call as the boiler feed waters in the case of industries. So overall, when we are checking the BOD of the incoming water and outgoing water, right, we'll come to know the organic pollution as well. So that means if we have to carry out BOD test, then DO test is the primary requirement. So these are some of the environmental significance, and already I told you that how the correlation of dissolved oxygen and temperature is there. So the fresh water at 0 degrees Celsius will have a dissolved oxygen concentration of 14.62 mg per liter, and the same water, if it is heated to a temperature and if its temperature is brought to 30 degrees Celsius, in that case the dissolved oxygen concentration will be somewhere around 7.62 mg per liter, right? So that means due to increase in the temperature, so we will usually consider the temperature variation plus or minus. So if we are talking about 30, that means plus or minus if you consider also. So that means that dissolved oxygen concentration is going to be decreased by 7 mg per liter. That means a fresh water having a dissolved oxygen concentration of 14.62 mg per liter at 0 degrees Celsius. And if you check for dissolved oxygen concentration of the same water, but its temperature is 30 degrees Celsius, in that case, it is going to be equal to 7.62 mg per liter. What is the difference we are going to get? Around 7 mg per liter. This 7 mg per liter drop is due to temperature variation. So that we need to consider. Now the question comes, how the dissolved oxygen in the water can be determined. So we have got the method something called as azide modification or Winkler's method. I repeat, we can determine the dissolved oxygen either by Winkler's method or azide modification method. So that is what I can tell you. What is the procedure for conducting the dissolved oxygen test? The procedure for conducting dissolved oxygen test is we need to have a BOD bottle of capacity 300 ml with a stopper. So we are going to have a BOD bottle of 300 ml volume. To this, what we'll be doing? So we'll be collecting the water sample in the BOD bottle. Regarding how to collect the water sample or wastewater sample, already I have told you people in the yesterday's class. So there is slight difference between collection of the water sample for DO test and collection of the sewage sample or wastewater sample for the DO test. So whenever we are going for the BOD test of the water, the full bottle will be filled with the water. That means we are going to collect 2 bottles for BOD test. For DO test, only 1 BOD bottle is sufficient. Similarly, if I am going for BOD test of wastewater, I need to have 2 BOD bottle. And if I am going for DO test, I need 1 bottle, right? So anyway, today's class will be with respect to DO test of water, not wastewater. So slightly, I'll go ahead with respect to the explanation that is connected with DO test. Let us say we are testing the water sample for DO, that is dissolved oxygen. So in that case, you need to completely fill the bottle with the water that needs to be checked for the DO. That means what is the capacity of the bottle? It is 300 ml. Sometimes what happens when we are saying 300 ml, so the bottles that we have purchased may not be of a particular grade, right? So that means if we are not having a grade, right, glassware, let us say we are having C grade glassware. In that case, there might be variation in the volume of the bottle that is being concerned. So it might be of 290 ml capacity or it might be of 310 ml capacity. So we need not have to believe the value that is being written on the bottle as 300 ml. You need to first measure the capacity of the bottle. So how to check whether the whatever the bottle that is capacity is mentioned is correct or not? For that, you need to fill the water completely. You need to close the mouth of the bottle with stopper after filling the water. Then remove it. That means excess amount of water will be removed by closing the cap. That water will be transferred in the measuring cylinder. There you check whether it will give exactly 300 ml capacity reading or not. So there might be variation. So you just make a note of it. If you get 290 ml, you make a note of it. If you get 300 ml also, you make a note of it. If you get 304 ml also, you make a note of it. If you get the volume of the water that is being filled in the bottle as 310 ml, you just make a note of it. It is required. Why it is required, we'll come back to that little bit later. Okay. So first you will be measuring the capacity of the bottle by making use of distilled water. After that, you will be collecting the water sample in the BOD bottle. of whatever the capacity it has, you are going to close the cap. That means a clean BOD bottle of 300 ml capacity, let us say its capacity is 300 ml in the present case. So a clean BOD bottle of 300 ml capacity will be taken, and wherein it will be completely filled with the water that needs to be checked for the DO test. Close the cap. That means excess amount of water that is being filled above the neck of the bottle will be spilled out, or it will be wasted. Remove the cap. Now it's time for adding manganese sulfate, that is MnSO4, that is around 2 ml. That means pipette out 2 ml of manganese sulfate, and you need to add it dropwise. How to add it? So you need to add it at the bottom of the whatever the opening of the pipette is there, that should touch the bottom of the bottle, that is inside bottom surface of the bottle. Why? Because already you have filled the water to capacity, to the full capacity of the bottle. That means since we are adding 2 ml extra, that means the upper surface water will be getting wasted. Similarly, you will be considering 2 ml alkali iodide azide, and you will be adding it in the same bottle. So such that it will be moving from bottom to top. That is what the requirement is going to be. So I repeat, you are going to take a BOD bottle. Let us say its capacity is 300 ml, and you are going to completely fill the water in the bottle, and you are going to stopper it. You are going to close it with the stopper. Excess amount of water will get wasted. Remove the stopper. Add 2 ml of manganese sulfate and 2 ml of alkali iodide azide. Right? Close the stopper or stopper the bottle. Invert the bottle 3 to 5 times so that mixing will take place. Now you need to check for what is called as the precipitate. You might get any one of the precipitate. Either you might get white precipitate or you might get brown precipitate. White precipitate indicates that the DO is absent. That means the DO test has failed. This is due to either wrong sampling method, the timing of the sampling is wrong, or the method adopted for the sampling is wrong, or the location of the sampling is wrong. I repeat, if you are going to get a white precipitate after adding 2 ml of manganese sulfate and 2 ml of alkali iodide azide to 300 ml BOD bottle, which consists of the water that needs to be checked for the DO test. In that case, any one of the conclusions can be drawn. The DO is absent due to either wrong time or wrong place, or due to the wrong method that is being adopted for the sampling. The DO might also be absent because there might be heavy pollution. First, we'll be checking for the sampling method, sampling location, and time of the sampling. Then we'll be checking for whether actually any pollutant is coming over there and joining, and because of that the DO is absent, because of which we are getting white precipitate. That needs to be checked. That means the experiment has to be repeated again. Okay. Anyway, if you get a brown precipitate, that indicates that dissolved oxygen is present. That means the manganese is being oxidized. That means Mn plus 2, right, has been oxidized to Mn plus 4. And because of which we are going to get the brown precipitate. If you are going to get the brown precipitate, then you will be following the further steps. If you get the white precipitate, again, you have to carry out the test once again, right? Before you carry out, you should make sure that the sampling method and time and the location is correct. Otherwise, there is no point. Every time you will get white precipitate only. So what was the explanation I have given? So you will be taking 300 ml bottle, BOD bottle. Then you will be collecting the water sample. You are going to close it with a stopper to spill out the excess amount of water or waste the water which is in excess. To this one, we will be adding 2 ml of manganese sulfate and 2 ml of alkali iodide azide. You are going to invert the bottle after closing the cap. So you need to invert the bottle 3 to 5 times so that mixing will take place. In case if you get white precipitate, DO is absent due to many reasons as already I have discussed. If you get brown precipitate instead of white precipitate, that indicates that DO is present. Brown precipitate indicates presence of DO, right? So in that particular case, we'll be following the further step. If once you get the brown precipitate, to dissolve the precipitate, we'll be adding what is called as 2 ml of concentrated sulfuric acid, concentrated H2SO4 of 2 ml will be added. Whenever you are pipetting out a concentrated acid or alkaline solution or any solution, you should not go for mouth pipetting. You should make use of pipette balloons. Right? You can just go through one of the video that is being uploaded recently in the YouTube for determination of chloride concentration in the water sample. Okay. So how to make use of pipette and pipette balloon, that is being shown in that particular video. So after getting the brown precipitate, we are going to add 2 ml of concentrated sulfuric acid. Again, you are going to close the cap and invert the bottle 3 to 5 times so that it will get completely dissolved. Now what will be done is you will be keeping the sample as it is for 2 minutes so that the dissolution process will get completed. Once the dissolution process gets completed, we will be pipetting out. That means a full 300 ml capacity bottle is there, wherein water sample is present, already 2 ml of manganese sulfate and alkali iodide azide and 2 ml of concentrated H2SO4 is being added to it, right? So this solution which is present in 300 ml BOD bottle, out of which we will be considering only 203 ml. We will be considering how much? We will be considering only 203 ml of the sample. Now you can ask me, why 203 ml? Why not 100 ml? So we'll be considering 203 ml for the titration process. Now the question comes, why? Because when I have considered 300 ml water sample, in this water sample to check the precipitate, right? I have added what? I added 2 ml of manganese sulfate and 2 ml of alkali iodide azide. That means out of 300 ml, 4 ml got wasted from the top surface. Excess amount of that particular water got wasted because of addition of 2 ml of alkali iodide azide and 2 ml of manganese sulfate. That means what is the quantity of the water sample present? The quantity of the water sample present is 300 minus 4, that is 296. If I am going to check, right? So how much sample needs to be taken, right? So that is corresponding to 200 ml of original sample. If I am checking for 200 ml, that means it is going to be 200 multiplied by 300 divided by 300 minus 4. That means 200 multiplied by 300 divided by 296. You will get around 203 ml. Let us say the bottle that you have used for your experiment purpose has a capacity of 310 ml, right? So in that particular case, the calculation is going to be different. If let us say your bottle capacity is around 290 ml, okay, let me give the example. So let us say the bottle capacity, actual capacity is 290 ml, but it is being mentioned on the bottle that 300 ml is the capacity. But when you actually measure, it is 290 ml. So that means in that particular case, what will happen? 200 multiplied by 290 divided by 290 minus 4. Again, you will get how much? You will get 203 ml. Because you are going to check the quantity of the sample to be taken for the titration, that is corresponding to 200 ml of the original sample. So that's why I am multiplying by 200. So 200 by 290 divided by 290 minus 4. Or if the bottle capacity is 300, then 200 multiplied by 300 divided by 300 minus 4. You are going to get how much? 203 ml irrespective of the bottle capacity. Okay. So that means that 203 ml will be pipetted out in a clean dry conical flask. So you are going to pipette out 203 ml of the solution. To this one, we are going to add 2 to 3 drops of starch indicator. I repeat, 203 ml of the sample will be pipetted out in a clean dry conical flask. To this, we'll be adding 2 to 3 drops of starch indicator. Whenever we consider starch indicator and when we are talking about dissolved oxygen, the titrant that will be considered in the burette is going to be sodium thiosulfate of 0.025 normality. I repeat, whenever we go for DO test, right, we'll be considering the titrant in the burette as sodium thiosulfate of 0.025 normality. That means the 203 ml solution that is being taken and to which 2 to 3 drops of starch indicator is being added, it will be titrated against sodium thiosulfate of 0.025 normality. Whenever we add starch indicator, the color change is going to be blue. The final color change after the titration is going to be colorless. That means 203 ml of the solution, when it is being mixed with 2 to 3 drops of starch indicator, the color changes to blue. It will be titrated against sodium thiosulfate of 0.025 normality till the color changes from blue to colorless. So note down the volume of the titrant consumed to change the color from blue to colorless. Let us say I will get 5 ml. Initial burette reading is 0 and final burette reading is 5. 5 minus 0, I am going to get 5. So what is the dissolved oxygen? The dissolved oxygen is equal to burette reading multiplied by normality of the titrant multiplied by equivalent weight of the oxygen. Always will be checking for the equivalent weight that corresponds to final result required. So when I am talking about dissolved oxygen, that means I need to take equivalent weight of oxygen. Whenever we are talking about normality, we should consider the normality of the titrant. That means the burette reading multiplied by normality of the titrant multiplied by equivalent weight of oxygen divided by what is the volume of the sample that is being taken? 203 ml. Why 203 ml? Already I have told you. Right? It is in terms of ml, but I want it, the denominator value in terms of liter. So into 10 to the power minus. So it will go to numerator. So because of which the dissolved oxygen in mg per liter is equal to burette reading multiplied by normality of the titrant. What is the normality of the titrant? What is the normality? 0.025 is the normality of the sodium thiosulfate. That means burette reading multiplied by normality of sodium thiosulfate, that is 0.025 multiplied by equivalent weight of oxygen, that is 8 multiplied by 1000 divided by 200. So since we have got the burette reading as 5, so that means 5 multiplied by 0.025 multiplied by 8000 divided by 200. So you will get how much? Nearly 4.9 mg per liter. Yes, you will get around 4.92 mg per liter. So it indicates what? It indicates that the dissolved oxygen in the water is more than 4 mg per liter. But however, if we are checking for good quality water, we cannot classify this water under good quality water. Right? So that means the dissolved oxygen of very good quality water will be more than 6 mg per liter. But here we are getting nearly 5 mg per liter. So that's why it has got some pollutants in it in terms of the organic matter. So this is what I wanted to discuss in today's class. So if you want me to repeat, I'll repeat. If you have any queries, you are free to ask the questions.
Excuse me, sir.
Yeah.
So what is that 8 in formula, sir?
That is equivalent weight of oxygen, I have told, no? Molecular
Okay,
weight of oxygen is how much? 16.
16, sir. Sir.
Yeah, 16. We are talking about equivalent weight.
Yes, sir.
That will be divided by 2.
Okay,
You will
sir.
get 8.
Yes, sir.
Because see, molecular weight of oxygen when I'm talking is O2. Equivalent weight is
Yes, sir.
divided by 2. So it will be 8. So I repeat, the formula for dissolved oxygen is burette reading multiplied by normality of the sodium thiosulfate multiplied by equivalent weight of oxygen multiplied by 1000 divided by 203. You can simplify it. You will be writing it as burette reading multiplied by 0.025 multiplied by 8 multiplied by 1000 divided by 203, or you can simplify it 0.025 multiplied by 8000 divided by 203. That means you are going to get 0.985. So dissolved oxygen in mg per liter is equal to burette reading multiplied by 0.985.